So suppose I have two vectors. When we looked at scalar multiplication, all we did is multiply by a constant, in the sense, if I multiply by C, and I'll assume C to be 2, so I will have 2 times V1, V2, which will give me 2V1 plus 2V2. In other words, I'm just distributing 2 to each element of the vector. Distributing 2 to each element of the vector. But when we mention dot product is not the same as a scalar product or scalar multiplication. So what we did last time, scalar product or scalar multiplication, is not the same as dot product or what we're about to do. So suppose we have the two vectors V and W. The dot product of V and W is V, well, you put a dot, hence the name dot product. V dot W. One thing that we do traditionally, when we write a vector, we write it in terms of columns, in the sense that is a column and that is a column. That's how we write it. But when we get to the dot product, the first vector in the dot product, we flip it and write it as a row. So V1, V2, W1, W2. And you may find this trivial now, but the reason for this goes to matrix multiplication and in general dealing with matrices. So how do we write the dot product? I always tell students that this is like running over a cliff and jump. It's pretty morbid, but easy to understand, I guess. So that is the direction, and as you go in that direction, you're just multiplying elements. So as I run, starting with V1, and when I jump, the first thing that I would encounter is the component W1. So V1, W1 plus the second element, V2, W2. And that would be the dot product. If I extend this to higher dimensions, say a 3-dimensional vector, a 4-dimensional vector, the process is exactly the same. I'll show you in a bit. You have to know, when we do a scalar product on a vector, the result is a vector, but the dot product of two vectors is always a number, in other words, a scalar. So whatever answer that you get that would be a scalar. In this sense, it would just be a number. As an example, suppose I have V1, 2, W minus 1, 4. Hurts me to write that way. 1, 2, minus 1, 4. And we want to find the dot product. So V dot W, the very first vector in the dot product, we typically flip. So the column becomes a row. So we have 1, 2. W is negative 1, 4. And run, jump. And as you go along, you just multiply. So 1 times negative 1 plus 2 times 4 minus 1 plus 8, you get 7. And as I mentioned earlier, the result will be a number. In other words, a scalar. It is not going to have a direction. So I want to find V dot W. The first one I flip. The second, I write it that way. So 1 times 2 plus negative 1 times 4. 2 minus 4, we get minus 2. I can extend the idea to higher dimensions. For instance, if I have one might think, oh, that has to be complicated. Well, it's not. So all I have to do is flip the first vector, 1, 0, 1, 4, 1, 2. Run, jump. So 1 times 4, 0 times 1, 1 times 2, 4 plus 2, I get 6.